Okay, let's do number 4 now. You might want to pause the video and try this by yourself and then come back here. Okay, so we got 30 grams of iron 3 phosphate. First of all, you have to know how to convert that into chemical formula here. So iron 3, so we got Fe, that has oxidation number 3 plus 3. Phosphate is also minus 3, not also, but you get the idea. So PO4, so this is plus 3, this is minus 3, so you don't need any subscripts. Okay. Balance wise, electron wise, what is it, oxidation number wise, they're all balanced out. Plus, combined with sodium sulfate. The sodium is plus 1, and then sulfate is SO4, that's a 2 minus, so you need 2 of these. Okay, so each one is plus 1. This is minus 2, so you need to, in order to balance it, you need two of the sodium ions there. That will yield, let me see, double replacement. So we have a partner swap. So Fe will bind with SO4. So let's do that. SO4, but remember, this is, what is it? 2 minus. This is plus 3. So you need 2 of the iron to balance up with 3 of the sulfate. So that 3 goes there, that 2 goes there. So let me rewrite that. So you don't need parentheses for Fe, just need 2 of them. So iron sulfate, you need 3 of them. Plus, what's the other one? Sodium. Remember that was phosphate was 3 minus, so you need 3 of the sodium. And then phosphate right there. Okay. And then we need to balance it. Okay. Shrink this a little bit. Let's balance now. Let me see. Fe wise, we got 2 over there. We have 2. So I'm just going to put 2 in front to have 2 Fe's. And then that made phosphate ion, 2 of them. So we need 2 over here because I want 2 phosphates right there. So you got to think of, don't look at P and O individually like that. Since it's phosphate ion, it stays as a phosphate ion, so treat it as one thing. Then I now have, what is it, 2 times 3? 6 sodium, so I might need 3 over here. That will make 3 sulfates, and I have 3 sulfates over here. So everything's good now. 2, 3, 1, 2 ratio. Okay, so it's balanced. Now we have, what else we have? Let me see. We got 30 grams of that, and then 25 grams of that. Again, we have to figure out which one's limiting reactant. Okay, so let me quickly find the molar mass for your FePO4. That should be 150.82 grams per mole. Molar mass for that. And molar mass for this should be 142.04 grams per mole. These are molar masses, not the amount that we start with. And then iron sulfate, that is 399.88 grams per mole. You can use periodic table to add all these up. Let me see. Yeah, that should be, let me double check. That's 142 and that's 150.82. Okay, now we could start. Let's start with 30 grams of iron 3 phosphate. So initially, let me write it on top. We were given 30 grams of this and then 25 grams of this. So we'll start 30 grams of iron phosphate, and we wanna go all the way up to iron 3 sulfate. This is a product that we want. So they actually got, this is experimental yield, right? 19.9 grams of it. Okay, we're pretty sure we're gonna get theoretical yield that's greater than this. Okay, let's go. So molar mass for FePO4, it's 150.82 grams for 1 mole of FePO4. And then I'm not gonna, you get the idea, FePO4 written here. And then for every 2 moles of FePO4, we're gonna produce 1 mole of Fe2SO4, 3. But we want grams, so 1 mole of Fe2SO4, the whole thing, 3, equates to 399.88 grams of it. Whew, a lot of writing here. So 4, 3. Okay. I'll use my calculator. I don't think you could see my calculator, but I'm actually doing it right now. 30 times 399.88 divided by, again, if I do something wrong, please write something in the comments, say so. Okay, I might make mistakes here. I want to fix it if I make mistakes. So don't blindly go with my own calculation. You guys have to check here. So let me see, 3 sig figs, so 39.8. Okay, 39.8 grams. Okay, of this, right? Okay. Next, let's assume we're gonna use up all 25 grams now. 25 grams of the other guy, Na2SO4. We'll do the same thing, but with different molar mass, of course. 142.04 grams of Na2SO4 equals 1 mole, because that's molar mass. That's 3 mole of Na2SO4. That's 1 mole. My handwriting's getting sloppy here. Fe2SO4, 3, and then same thing, 1 mole Fe2SO4, 3. Make sure you know all the steps that I'm taking right now. Okay, you gotta understand what we're doing right now. 399.8 grams of Fe2SO4. That yields, let me make some more room. Okay, calculator party again. 25 times 399.88 divided by 142.04 divided by 3 gives me 23.5-ish. 23.5 grams of Fe2SO4, 3. Okay, which one gave us less? Well, Na2SO4 gave us the less amount of the product, which means that is the limiting reactant. So this guy is limiting reactant, this guy is excess reactant, but they're not asking you for that in this case. What is a percent yield? Remember, in the problem they said they actually got experimental yield is 19.9 grams of it, but theoretically, this is theoretical yield, 23. You're supposed to get about 23.5 grams of it, and percentage, so let's just multiply by 100%. That's how you get the percentage. So let's actually do that. 19.9 divided by 23.5, and then when you multiply by 100%, it's going to be 84.7%. So that's how you get your percent yield. Let's move on to the next problem now.